The last set of exercises to calculate the volume of a solution that contains a certain number of moles are going to be in these three examples. The information is always given as the molarity and the number of moles or grams. If the number of moles are given, we can calculate the volume in liters through this formula. If we need to calculate first the number of moles, we need to use the mass given and the molar mass of the substance to calculate the number of moles first, and then we are going to apply the second formula. In this first exercise, they give us the molarity of the solution and the number of moles that contains. So we have the number of moles and the molarity, and we can calculate the volume. That's what we are going to do. So the first step, we're going to be expressing the information about the number of moles and the volume. Remember that the volume is going to be obtained in liters because the molarity is defined as the number of moles divided by the volume in liters of solution. So in this case, the volume is going to be the number of moles divided by the molarity, and this is going to give us the volume in liters. The number of moles is 0.6, the molarity is 3, so the volume is going to be 0.2 liters. They are asking us the volume in liters, so the answer is 0.2. In this second example, we have the molarity and we have the mass. So the molarity is in this formula and the mass is in this formula. So we need to calculate the number of moles first using the molar mass and then apply that number of moles here so we can calculate the volume. So first step, we are going to calculate the number of moles of sodium carbonate. For that, we need the molar mass of this one. So the sodium is 23 times 2 plus carbon is 12 plus 16 of the oxygen times 3, which is 48. So the molar mass is going to be 106 grams per mole. With this molar mass that we need here and the mass that we have, which is 26.5, we are going to calculate the number of moles of sodium carbonate. So again, the number of moles is equals to 26.5 grams divided by the molar mass, 106 grams per mole. This one is going to give me 0.25 moles of sodium carbonate. Okay, now the second step is going to be using this number of moles and using the molarity, the number of moles and the molarity. We are going to divide the number of moles divided by the molarity, and we are going to obtain the volume of the solution that we need to extract. So the volume is the number of moles divided by the molarity. So the number of moles is 0.25, the molarity is 0.05 molar, this is moles, this is mole per liter, or decimeters cube in this case, decimeter cube, which are equivalent numerically. So the answer for this is 5 decimeters cube. If they ask us in the volume in decimeters cube or liters, it's going to be 5 liters. If we need to pass this to centimeters cube, which is not the case, we can calculate this one. So 5,000 milliliters would be the answer. In this case, out of these, the answer would be 5 decimeters cubed. In this last exercise, we have to obtain 19.6 grams of sulfuric acid, but we only can use a solution that is available for us, that is 1 molar. So we need to do something so the 19.6 grams are exactly in some volume of this 1 molar concentration. We have the molarity, so we can see that the molarity is the number of moles divided by the volume. The problem is that we don't have the number of moles. So first we need to calculate the number of moles using the mass over the molar mass, and then we are going to plug it in here to obtain the volume desired of the solution that we want to prepare or we want to use. So let's do the first step. The first step will be calculating the number of moles present in this amount of grams, 19.6 grams of sulfuric acid. We know from any exercises before that the molar mass of sulfuric acid is equals to 98 grams per mole. That means that in 98 grams of sulfuric acid we have exactly 1 mole. You can do the calculations here. Now, the number of moles then is going to be the mass that we have divided by the molar mass. So it's going to be the mass divided by the molar mass. In this case, the mass is 19.6 grams of sulfuric acid divided by 98 grams per mole. This calculation gives us 0.2 moles of sulfuric acid that we need to extract from the solution. The thing is that we have a solution 1 molar and we need to extract 0.2 moles of sulfuric acid. So in the second step, we're going to calculate the volume, and if you see, the volume is the number of moles divided by the molarity. In this case, the number of moles is 0.2, which is calculated in the first step, moles divided by the molarity. 1 molar, it means 1 mole per decimeter cube. Okay, so we are going to obtain the volume in liters or decimeters cube, which is going to be 0.2. The problem is that we do not have the volume in decimeter cube. We want to calculate the volume in centimeters cube, so we need to multiply that by 1000. So the solution is going to have the number of moles that we require in 200 centimeters cube in this case, or 0.2 decimeters cube. This is not the only way of calculating this, but this is the one that I think is going to be easier for you.